Good evening to all of you.
Good evening.
How are you?
Good evening, sir.
Good evening too. Now, to our class. Last time, Joseph, what were you discussing? Joseph? Hey, Joseph, you're not in class last time we met.
We were doing risk and return.
You're doing a risk and return.
Yes.
Okay. Okay, let's have a recap of what then we were discussing at that point in time. So we introduced on risk and return. And I say that return are the expected cash flows that as a holder you will be receiving over a given time period, okay, over the next 1 year, over the next 2 months, okay, over the life of that particular investment that you have chosen, okay. So simply, the return is the cash flow in whatever format it will come, okay. In case, for example, you are an equity shareholder, what is your return, by the way? In case you are an equity shareholder, what form does your return take?
Dividends issued.
The first thing will be the dividend, okay? Don't forget, in case you are an equity shareholder, one of the way you do get the return are the dividends the company pays you. What else?
Bonus.
Yeah.
Bonus in shares.
Bonus, in a way, it's a form of dividend, by the way. So bonus, or something referred as a script issue, is a form of dividend. So in the next form of the return you receive is a capital gains, okay, which I think I did mention last time, okay. So the dividend and the capital gain, the increase in the value of the share, okay. If you bought the share at a price of 20, now it's 6 months later, since the time you bought them at 20, and the current share price is 23. So definitely you have earned from your investment. You bought at 20, now it's 23. So you have made a capital gain of 3 Kenya shillings. So definitely, therefore, that's another way that your return, another way you as shareholder, your return will take the form of. In the case of a bondholder, or in case let's say the case of bank that has issued loans to customers, what form does the return, the return takes?
Interest.
Of course, the interest. Thank you. Of course, the interest. Okay. In case the bank has issued a loan, the return they are anticipating, they are expecting to receive is in form of the interest. Okay. In case you are a bondholder, also don't forget this is not a loan. Okay, it's a form of debt financing. You also get an extra because sometimes maybe you may buy a bond, okay, at let's say 95, okay. Then at the point of redemption, that is when the money is going to be in quote returned back to the buyers of the bonds. Okay, the company that issued the bond can say that we are going to be buying every bond from our investors, not at 95, the price we sold them at, but at let's say 102. Okay, so therefore you as a holder of a bond holder, you also get the interest plus the capital gain. Okay, because you bought the bond at 95 and the company is going to pay you back at 102. So definitely you also making some return. In this case, the return takes the form of also the capital gain. Okay, in case this is a tradable debt instrument. Okay. We went ahead and discussed on the case of risk, okay, and you say the risk is the variability, okay, of the return from what was expected, okay. So comparing actual versus expected, okay. What is actual return you be receiving? What were you expecting? If there's going to be a deviation between the two, then that's referred to as risk, okay. Don't forget in case there's no deviation, there's no risk at all. Okay, so the risk comes in case this can be therefore a deviation. Okay, deviation of the actual return from what the holder was expecting. If the two are equal, I think when we discuss if the two are equal, the actual is equal to what was expected, then of course don't forget you have zero risk. Okay, there is no risk. Okay, therefore we assume that here this is not a risk-free asset. Okay, don't get an asset where the actual return is equal to what was expected is what referred to as a risk-free asset. Okay, so there's no risk at all. Okay, in case, for example, the T bonds, okay, treasury bonds. Okay, so all the government issued bonds generally we assume that they do have zero risk. Okay, therefore the risk-free assets. Okay, either way that we're not discussing on risk-free assets. Okay, we assume that these assets are risky assets. Okay. We can discuss one of the way we can measure risk. Did we discuss on how to measure risk? I think we did. I'm not sure. Lillian. Lillian. Because I think if I remember, we did introduce on risk. What did we cover the risk?
Let me confirm.
Okay, confirm. Have you confirmed?
Yes, I think.
Mm-hmm.
Yes, I think we did. Yeah, risk. We covered risk.
So what other risks did we discuss?
We did an illustration.
Okay, where there was probability distribution.
Yes.
And we got the risk.
Yes, I think.
Yeah. Did we discuss on how to get variance? I don't think we went to that. Did we discuss how to get variance? No.
No, we did probability, the expected return actually.
It was only on the return side.
Yeah, expected return.
Okay, fair enough. Okay, let's begin the first measure of risk then. The use of variance. First measure of risk, the use of variance. Okay. Now, variance generally we normally, okay, mathematically we can define as the deviation. No, there's what we call the return that we are expecting. Okay, I think I did mention here. Okay, the return that we are expecting. Now, the variation of the deviation of the actual return from what we were expecting squared is what we call as variance. So variance, essentially, we can define it, okay, as the sum of deviation squared. Okay, that's what it's called. That's what it is defined. Variance is more defined as the sum of deviation, of course, from the mean or the expected, from the mean or the expected returns squared. That's what defining mathematical variance as. Okay, the sum of deviation. Okay, that is from the sum of deviation of return. This I think I should add here. The sum of deviation of returns. Okay, sum of deviation of return from the mean or the expected return squared. Yes, that should be the way. Yes, that way. Okay, that the variance is the sum of deviation of returns. Okay, the return you'll be receiving. Okay, from the mean. Now those deviations squared. Okay, It's also referred to as the variance. Okay, I hope this is not something new to you. I think you've done this in your high school, your O levels. So then, therefore, we can summarily say that variance, okay, I will represent it as sigma, okay, variance, okay, is equal to, I will say that it is sum of deviation squared, okay, so the mean, okay, where is the mean? The return, okay, the return minus the mean return, okay, squared. That's simply what we refer to as the variance, okay. In case, for example, we are analyzing, okay, I say that, for example, we are trying to analyze the data set, okay, from population, okay, again, scenario A, we just call it scenario A, okay. You're trying to analyze the data set which is from population. In short, you're trying to analyze the entire data set, okay. If you're trying to analyze a company share price, you can analyze from since the shares were issued up to date, okay. Now that's an entire, okay, that's a population, okay. So we assume that in case we're doing the case of population, how do you get the variance? Okay, the variance will be equal to, let me represent R as the return, okay, and this is as a mean, okay, R bar to mean the mean, okay, okay, squared, we divide by N, okay, where, just represent here, where this is the variance of the return, okay, R is equal to return, R bar, of course, this is the mean return or the return expected, mean return, and N is equal to the number of observation, okay, number of observations, okay. It's not, if for example you're trying to analyze 1 year and you have arranged the data set in such a way that they are monthly, they have how many observations will you be having? If you're trying to analyze the data set on a monthly basis, in a year, how many data sets will you be having? How many observations will you be having? Because you'll be
12.
having 12. Yes, you'll be having 12. Okay, you'll be having 12. So N represents the number of observations. Okay, in your data set, how many do you have? In your data set, how many do you have? That call the number of observation. Okay, and that's how we analyze for the case of population. Okay, that's how we get the variance in the case of population. As you can see, by the way. Okay. Yes. Someone has a question. Okay. So as you can see, don't forget we say that risk is a measure of variation or deviation of the return from the mean, from what we're expecting. Therefore, in case the deviations are higher, is the risk high or low? If we end up with having high variance, for example, okay, what do we conclude? Does that population has a higher risk or low risk? In case we have, let me just give an example, okay? We have A, we have B. A has a variance of, let's say, 15% squared, and this has 13% squared. Now, which of the two is more risky? A or B?
A.
Of course, A, okay? Okay, A, it means therefore there's more deviation from what we're expecting. Of course, if you're expecting to get 10 and get 10, that's what you'll be really happy as an investor. But in case you're expecting to get 10 and you get 13, of course you'll be happy because this is a positive risk. But don't forget, you can also go their side, okay? So you can expect 10, you end up getting 5, okay? So therefore, of course, for investor, the more certain an investment is, the better off for you, definitely, okay? Because they've done it for those risk-free assets is of very minimum, okay? But generally, therefore, the more the deviation, the more risky it is to the investor who do invest in a particular asset. Okay? So that's the case of population. In finance, generally, okay, we rarely have data set for population. Most often than not, you're going to be analyzing a sample. You're going to be analyzing a sample. Okay? It'll be a sample analysis. Most of them to be a sample. And don't forget here by a sample, what we mean by a sample is that the data set you have used is an extraction from the entire population. Okay, The company, for example, you can decide to analyze the share price of the company since it was issued, okay, Safaricom in 2008, okay. So you can decide, I'm going to analyze this data set from 2008 to 2020, okay, as per today. Now that will be a population. But rarely are you going to do that, okay? That's too much, the data you have, you'll be analyzing, okay? So why don't you just take a year, for example? I'm going to analyze maybe 3 years out of the possible 13 years, okay? So you're going to be analyzing a part of the population. That's called a sample. You'll be analyzing a sample, okay? If that's the case, therefore, what happened, therefore? You can see, therefore, the variance of the sample, okay, the variance of the sample, okay, the sigma, sorry, not the best, sigma. Hey, what happened here? Okay. Will be equal to the variance deviation squared n minus 1. Okay, n minus 1. Okay, so you're going to be having observation minus 1. Okay, that's in case you're trying to analyze a sample. Okay, n minus 1. Okay, sorry, this should be sum. Okay, let me actually qualify this to be sum, this summation. This, the sign here is some sum of deviation from the first set all the way to the last set. Clear? And as I've mentioned, okay, in finance, let me just clarify here. So generally, in finance, generally, the data set that is in finance, I'm not sure about their units, generally in finance, is assumed to be a sample unless otherwise informed. So generally, when you're going to be analyzing data set, we assume that is a sample, okay, unless otherwise. So generally, we assume that the data set to be analyzing is a sample, okay, it is not a population. So in case you're given the following, the share price for this particular company, you're not being told whether this is a sample, this is a population. So generally, we assume that it is a sample, okay, generally. Okay. What if you're attempting to analyze data from probability distribution, You're attempting to analyze to determine the variance, okay, and the data you have is from probability distribution. Like the case we did last time, okay, don't forget that data set is from probability distribution. Hope you sure I have that example with you, okay, so that in itself is probability distribution, okay. If that's the case, therefore, how do you get the variance? The variance of the probability distribution will be equal to the sum of deviation probability multiply by deviation from the mean, from the first data set all the way to the nth data set. This is I is equal to 1. What's happening? Where I is equal to 1 from the first data set all the way to the last data set. Okay. So first, of course, is to get the mean. Once you have the mean for all the cases, whether population, whether from a sample, whether from point distribution, of course, you have to get the mean return, the return expected. Okay, you get the deviation. Okay, square the deviation, then you multiply by the probability. Now the sum from the first data set all the way to the nth data set. Okay, assuming the data you have used is from probability distribution. Okay, like I mentioned, like that example we did for the return expected, okay, in itself it is from probability distribution. Clear? Question? Okay.
What does I mean?
So I is, it can be, it's just a symbol. It can be K, it can be N. It just means that you want to analyze from the first set of data which we are calling I, which is the first, where I is equal to 1. I can be anything. It's just a symbol we are used in math, not like it means anything. Or from I to N. It can be K, where K is equal to 1. Sometimes even K is used. Not that it must be an I, no. Is that clear?
Yes, it is.
Okay.
Excuse before we move on. The summation symbol.
Yes, summation symbol, yes. Michael, I lost you.
Should it be summation or combination?
Oh, I totally lost.
Sorry, is it supposed to be a symbol or a combination symbol? I'm not quite sure.
I can't even hear what you're asking.
I'm saying.
Yes. No, it seems better.
The summation symbol, should it be, how will I compute it, where I thought it should be a combination symbol or something?
What do you mean compute it? I don't get it.
How will I key it in the calculator?
No, it's just a sum. You have to just represent. There are many summations. I'm not sure what's happening on my pen. So it just means that is a sum. It's only that I don't want to add many of them. It's just a symbol to represent sum of many different numbers with a sign.
Okay.
Yeah, it's just a symbol. Okay, here we go.
Okay, it's okay.
Okay. Okay, so that's on how we get therefore the variance, okay, for those three set of data, either from population, from sample, or from probability distribution. Okay, that's the first one. Okay, the use of variance analysis. Okay, now what if, let's now analyze in case you don't want to get standard deviation. Another measure of risk, okay, 2 is called the use of standard deviation. Based on standard deviation. Now, standard deviation, okay, is simply the square root of the variance, okay? Okay, the square root. Square root of the variance. Okay, it's the square root of the variance, okay? Which implies that for in case you're trying to analyze the sample, you just get the square root of the variance of the sample. If you're trying to analyze the population, the square root of the variance of the population, okay? Now, actually, standard deviation, most of the time, or not most of the time, okay, it makes more sense to be able to interpret it, okay, if you compare with the case of the variance, okay. Now, the variance, don't forget, these are squared, okay, let me just go back to here. These are squared, okay. Therefore, if, for example, this was the return were in percent, it means you're going to get percentage squared. Now, how do you interpret a percentage squared? It's a bit hard for you to make any interpretation. Now, standard deviation, okay, comes in and try to tell us. If, for example, we get a standard deviation, let me just give an example. Don't forget, you get the square root. Here it was percentage squared, okay, for the case of variance, okay. Sorry, guys, seem to have an issue with my pen here. Okay, we are saying that variance is percent squared, like we have just obtained from here, okay? It is percentage squared, okay? Now, if you convert it, you won't get a standard deviation, okay, to standard deviation. Don't forget, you're going to get the square root of that variance. So in case it was percent squared, it becomes therefore percentage, okay? So if, for example, the variance was, let's say, 9% squared, the standard deviation is 3%. Now, it becomes easy to interpret what does this 3% mean. don't forget to say that this is the deviation from the mean. And therefore, generally, okay, the return you'll be receiving as a holder is going to be 3% plus or minus what you are expecting. Okay, that's what the standard deviation means. Okay, plus or minus what you expect. In case you're expecting to get 10%, there's a chance you're going to be getting 13%, or in the worst case scenario, 7%. Okay, this is going to be the range of your returns. Okay, from 7% all the way to 13%. What it means, therefore, if we have a lower value, for example, we have 1%, not 3%, but 1%, and you expect to get 10%, therefore, return becomes either 11 or either 9%. As you can see, your return are closer together, okay, which implies therefore the risk becomes much more lower than the case of we have higher standard deviation, okay. And so therefore, the lower the standard deviation, okay, the lower the risk to the investor, okay. So the case of the standard deviation, okay, the case of standard deviation. Okay, so in case therefore you're trying to, you are analyzing, okay, and so that you're analyzing population. So you're analyzing the population.
Excuse me, sir.
Yes.
Okay, you've already deleted, but I wanted to say something on the calculation we did. It was like 9%
Yeah.
squared, and then the variation of it, we are like, it's 3. I think it's 9. The square root will cancel.
Yeah, square root, I got the cube root, yes. Thank you. It was meant to be 3 point something. I want to guess, isn't it? 3 point something.
Okay, because I'm saying the standard, it's 9. It's not even, because it's, the variance is like, it's 9 squared.
9% squared. And the square root?
Yeah, the square root of that.
Which you get 3%, isn't it?
No, it's 9. The square root and the cube root, the square root and the square cancels.
The square root and the, I don't get how they cancel.
Like 9% squared, it's 81, and then the square root of 81, it's 9.
No, okay, no, I get what you mean. So it is 9% multiplied by percent squared, which therefore this will give 3 squared, percent is squared. Then you get the square root, which will be 3%.
Okay.
You get it?
I mean it. So the 100, the percentage is the one that is squared.
Okay, it is a percent that is squared. If you remember how we got this percent squared, you had here value. Let me just take you back a bit, okay, to where we were discussing. Look, here there were returns, okay, in this point, the returns that we were getting here, okay. Assume that the return is, let's say 4%. The mean was 3%. Then you square the deviation, like you're just on here. You square it. The entire of this is squared. How it will be how much? It will be therefore 3 minus 1, which is 1%.
Yeah,
squared.
1%.
Therefore, it will become 1% squared. This is a percentage you're squaring. Or in case you don't use percentage, you just can use 0. Okay, 0.04 minus 0.03 squared, which will be equal to 0.01 squared. You get it? Which will be equal to 0.001. Isn't it?
Yes.
Yes. So that's the way. If you want to use percentage, you can use percentage. If you want to use decimal, use decimal. Actually, by the way, there's a time, because I think you find this case where you can get confused. Okay, because I've seen students in the past confusing. Should I use decimal? Should I use percentage? So just choose whatever you want to choose, but just be consistent. If you want to use decimal, use decimal. If you want to use percentage, use percentages. It's clear.
Okay, on the second part it's clear, but still on the 9% is the one that I'm still like.
Oh, the 9% squared. This one.
Okay, I think it's like if we do 0.09 squared.
No,
so
0.09.
Yeah, squared. It's so different with that.
Yeah, because it's different. Was this one, don't forget, let me just try to interpret for you. What's 9% square mean? 9% square mean it is 9% divided by 100 squared, which will be 10,000.
So, oh, there, okay, yeah, I get it now. Yeah.
Yeah, which is 9,000, which is 9 divided by percentage squared, which is 100 times 100 to give us 10,000. These are not the same. These are not the same.
Okay. So on the square root, you'll do the square root of the upper and the square root of the lower one.
On the square root, you do the square root of the upper. If I'm getting here.
Yeah.
Yeah, because this is 3, so it going to, therefore this was 9%, so it is 9% times percent squared, yes, therefore this is going to be equal to, is like 3 squared times percent squared.
Yeah.
3 times percent.
So, yeah, exactly. Yeah, I get it now. It's
Okay,
clear.
okay.
Thank you.
Okay. Yeah, it's cool. Thank you for asking that, because I've seen students making that mistake. Don't forget to be very careful. 9% squared, like the way she has just asked, okay? 9% squared is not equal to 0.09. Don't forget the 9% squared, sorry, is not equal to 0.09. 9% squared is equal to 9%, okay? You will divide by 100 squared, because you want, in case you want to convert to decimal, which is 0.00, I don't know how many zeros there are. I think I don't know how many there are, but anyway, that's how it is like. So be quite careful as you make those interpretations. Okay, so that's on the standard deviation. You see that it is simply, therefore, let me have both these. Okay, therefore, in case of population, therefore, you can say, therefore, you're going to have population be equal to, would be equal to the square root, the count of the variance, and the variance from the population, we got, okay, let me just first represent that standard deviation is equal to, standard deviation is equal to the square root of variance. Therefore, in case you're dealing with the population, therefore, the standard deviation, okay, now is not, it's just sigma with no square, will be equal to the square root of deviation. Yes, let me just present here. Let me just get the variance first. Sum of deviation squared divide by n and get the square root. If that's how you want to present it, get the square root. That give us therefore the standard deviation in case of population. In case you're dealing with a sample, therefore it will be equal to sum of deviation we divide by n minus 1 and get the square root. Simple as that. Okay, lastly, in case in case of probability distribution, probability distribution, therefore to be equal to the square root sum of probability, sum of probability times deviation squared. Simple. That's the we get it for the probability. There's the standard deviation. Okay, the standard deviation in case you're in case of probability distribution. Here. Okay, now your examiner does ask this question more often than not. Okay, this, yeah, for example, November 2019, let's do this question. November 2019, go through it. question 3B. November 2019, question 3B. Yeah, go through it, then we discuss together. Okay, I hope you have gone through it. Now, the examiner here is asking you to get in Roman 1, okay, the standard deviation for Y and for Z, okay? So let's do for Y, then I leave it to Z, okay? For Y, I have here, yes, can have a probability, then have here the return. The returns have 0.1, that's first outcome, 0.2, 0.35, 0.05, 0.15, 0.15. The return can be, that's for Y, can be 10%, 10%, but you can use decimal in case you want decimal, 12%, 8%, 15%, 14%, and 9%. The next bit, of course, you need to get the mean first, okay? Therefore, here the next column is to get the mean. I always should remember how to get the mean or the return expected, okay? So, of course, the first thing is probability. You can have another column here. Probability multiplied by the return. Probability times the return. Probability times the return. Therefore, first outcome 0.1 times 10, okay, which is equals 1, 0.2 times 12. Give us how much? 2.4.
2.4.
Okay, 0.35 times 8. And get
2.28.
2.28. Next outcome.
No, sorry.
How much?
2.8. It's
2.8. 2.8. 2.8. Then next is 0.05 times probability, the return 15%. To give us 7.5 or 0.75.
Yes. 0.75.
0.75. 0.15 times 14. And it goes
2.1.
2.1.
2.1. 0.15 times 9.
1.35.
1.35.
Yes.
Okay. The sum.
Yes.
Okay, to give us the mean return. So the sum of probability times the return is a mean, is equal to the mean return or the return expected. And you get how much?
Mm. 10.4.
10.4, because therefore the return expected. Okay, 10.4. But the question is not asking us about get the return. It's also about get standard deviation. Therefore, we can have another column here. Probability times the return deviation, isn't it? Probability times the deviation squared. The first outcome, probability is 0.1. The return is 10. Therefore, 10 minus 10.4 squared. The next outcome, 0.2. 10 minus, the return is 12, sorry. So the return here is 12, so not 10, but 12. 12 minus 10.4, the mean, squared equals 0. The next is 0.35. The return is 8 minus 10.4 squared. The next is 0.05. The return is 15 minus 10.4 squared. Then you have 0.15. The return is 14. So 14 minus 10.4 squared. Then the next is 0.15. The return there is 9. So 9 minus 10.4 squared. Yes, Akatu.
I'm getting 10.5.
Hmm?
I'm getting 10.5. 5.
10.5.
Yes.
Someone confirm 10.4, 10.5.
10.4.
10.4. Okay. Just do it again. Just sum them up together. 1 plus 2.4 plus 2.8. Akatu, what do you get?
Still 10.5. Ama nakosea wapi?
I'm not sure unless
Oh, yeah. I've seen the problem.
using the problem.
Yes.
Okay, fair enough. Okay. Then once we have this, we get a sum here. And the sum is going to give us the variance. And how do we get the sum? Don't forget your basic math.